So, picking up again on angles of polygons, we started this, seems like forever ago, but it was just a week ago that we started talking about angles of polygons. So, anyone remember the formula, we might as well review, for the sum of the angles of a polygon? Yes?
Minus 2 in parentheses times 180.
Nice. So the sum of the angles is n minus 2 times 180. And then if you wanted to find each individual angle for a regular or for an equiangular, what did you have to do? Yes?
Divide the total amount of degrees in the polygon by the number of sides.
Yeah, which is also the number of angles. So it's just n minus 2 times 180 divided by n. Let's see if someone else remembers something. What's the sum of the exterior angles?
360.
Yeah, it's always 360. So then each exterior angle how will we find that? Yes?
Divided by the number of angles.
Yeah, divide 360 by the number of angles, which is also the same as the number of sides. All right, so we're going to do some problems today. Some of them will be pretty straightforward, some of them a little less so, and we'll also do some examples of ones where you're given some information and asked to find the number of sides. Okay, so let's start with these. So here we're looking for the value of x, but what is this thing over here on the left? Yeah, what kind of hexagon? Well, not necessarily, but it is equiangular. So we have an equiangular hexagon over here on the left side, so we can figure out what the measure of each of its angles. So there, each angle is going to be equal to 6 minus 2 times 180 divided by 6. That's 4 times 180 divided by 6. It will be faster and easier if you don't multiply the 4 times the 180 and then divide by 6, because then you're making big numbers. 6 goes into 180 really nicely, doesn't it? How many times? 30 times 4 is 120. So each of these angles is 120. From there are two very different ways to figure out the value of x. I'll take a suggestion. One of them is not anything new. Yes?
I don't know what they're called. It's when there's a line and then a linear pair.
Yes, a linear pair.
So you find the other part of the pair.
Okay.
For
How?
Each subtract 120 from 180.
Yeah, the angles in a linear pair are supplementary. Subtracting 120 from 180 gives you that this angle is 60. And that angle is 60, and then what?
You can subtract the sum of the two 60s from 180.
Yeah, we know that the angles in a triangle add up to 180. So adding 60 and 60, that's 120. Subtracted from 180. This angle turns out to be 60 also. There is a very different way to do that. On this one, you don't have to, but there's a very different way you could do that. For a moment, ignore this line right through here. And instead of looking at this as a hexagon with a triangle taped to it, look at it this way. What is that whole big red thing now? It's a pentagon. It's got 5 sides. So we could find the sum of the pentagon. Let's see, that would be 5 minus 2 times 180, which is 540. And then we've got 1, 2, 3, 4 120s and x. Well, the 4 120s is 480. And look at that. We get the same answer. Probably not really any longer, maybe a little bit. All right, how about problem number 2? What kind of angles are these? Well, most of them at least. No, just individually. This angle, this angle, this angle, and x are all exterior angles. And the 115 isn't, but can we find the exterior angle? Sure, subtracting from 180 leaves this is 65. And what's the sum of the exterior angles supposed to be? 360. So we're just going to add 90 plus x plus 80 plus 65 plus 35. And that's supposed to be equal to 360. Let's see, that's 180, 270. So subtracting, we get x turns out to be 90. Any questions about that? All right. Then let's try these two. Again, here we have a couple of things stuck together. What is this up here? More specifically, an equiangular pentagon. So each angle of the pentagon is going to be 5 minus 3, 5 minus 2 is 3, my fault. That's what I get for thinking ahead. So 5 minus 2 times 180 divided by 5. So that's 3 times 180 over 5. You can multiply it first if you want, or you can divide 5 into 180, and that's 36 times 3 is 108. Now, unlike the previous one, where we could use linear pairs, we can use linear pairs to find this angle and this angle, because we know both of these are 108. But what kind of a figure is this down here on the bottom? Yeah, it's concave. Our rules don't apply to those. So what are we going to do? We're going to look bigger, like I showed you on number 1. What is this that I've outlined in red? Yeah, it's a quadrilateral. So the sum of the angles of the quadrilateral, that's going to be 4 minus 2 times 180 is 360. And so far we've got 108, another 108, x, and 85. Let's see, that's 216 plus 85 is 301. So x is 59 degrees, I think. Tell me if I did all the arithmetic right, yes?
Yes.
Okay, thank you. Yes.
This is just like, I'm not going to say a general question. It's just like a random question. If you were to, the angle that's on the angle of the concave.
This one?
Yeah. Could you take 108 from 360 and then have that other angle?
Yeah, and I'm trying to remember if it works out. You want to check real quick?
Sure.
So if this was 108, this is, this is 72. This would be 72. 108 from 360 would be 252.
Yeah, 252.
And this is a 1, 2, 3, 4, 5. This is a pentagon. The sum of the angles in a pentagon is 540. So you'd have 72. Pardon?
I'm like checking if it's 52. I may have. No, it's 52. I borrowed wrong.
Okay. So it'd be 72 plus 72 plus 252 plus 85 plus x is, what was it, 540?
Yep.
So let's see, that's 144, that's 396. 396 and 85 is 481. So it does work. It's just that we have to have angles that we haven't talked about, angles that are bigger than 180 degrees. Does it still work? Yep. It's actually easier if you do it the other way because it's fewer angles. But it's a good thought. All right. So now let's take a look at this one. This is going to use an idea that you just brought up. What do we know about the sum of these three angles? It's got to be 360. So far we've got 258. So that leaves what, 102 for this? Now we can just do the angles of a quadrilateral, and you probably have that one memorized already. What do the angles in a quadrilateral add up to? 360. So I've got 102 plus 78 plus 83 plus x is 360. See, that's 180, 263 plus x. So x is what, 97? As always, check my arithmetic. Okay, any questions about that? All right, the other thing we're going to do are some examples where you're given information and asked about the number of sides. We didn't do any examples of these earlier, but you had some homework problems on it. Most of you figured it out, but I figured I'd get some into your notes. So the sum of the angles of a polygon is 1,980. Find the number of sides of the polygon. Well, we know the formula says the sum of the angles is equal to n minus 2 times 180. So it's 1,980 is equal to n minus 2 times 180. At this point, you have two choices. You can distribute the 180, or you can divide both sides by 180. I personally always divide both sides by 180. Why? Well, I'm going to have to divide by 180 sooner or later. Might as well get it over with. So dividing both sides by 180, I get 11 is equal to n minus 2. So there are 13 sides. Relatively straightforward, just a little bit of algebra. For this next one, the measure of each exterior angle of a regular polygon is 12 degrees. Okay, well, we know that each exterior angle is equal to 360 over n. So we've got 12 is equal to 360 over n. How do I solve that?
Multiply by n.
Yeah, multiply both sides by n to get rid of the fraction. Then I have 12n is 360. Divide by 12. And I get that there are 30 sides. Okay? All right. For this last one, there are two different ways to do it. One of them is slightly shorter. I'll show you the longer way first, which is the way most students end up doing it. But if you can remember it, the other way is slightly shorter. It says the measure of each angle of a polygon, not exterior angle, but just regular angles. So you're like, okay, each angle is going to be equal to n minus 2 times 180 over n. So that'll be 150 is equal to n minus 2 times 180 over n. Multiply both sides by n again to get rid of the fraction. And I have 150n is equal to, now on this one, if I try to divide both sides by 180, I'm going to get something much less than a whole number over here, right? So, and I know that n's going to come out to be a whole number, so you could do that. It's just harder. So I'm going to go ahead and distribute the 180. It'd be 180n minus 360. Subtracting 180n from both sides, we get negative 30n is equal to negative 360. Dividing, we get n is equal to 12. There is another slightly faster way to do this. You have to think a little bit. And I know for some of you that's against your religion, but let me show you anyway. If the interior angle is 150, what's the measure of the exterior angle? 30. Oh, well, we know each exterior angle is equal to 360 divided by n. Isn't that going to be an easier thing to solve? Yeah. Not that the other one was terrible. Multiply by n. We've got 30n is equal to 360. Hey, look at that. Over here we had negative 30n equals negative 360. It's kind of cool that way that works out. So we get n is equal to 12 that way also. So either way is fine. All right. All right, I have a worksheet for you.
Yes.